Okay, so now today we'll continue mass analysis. So in yesterday's lecture, we saw how to solve this mass analysis, means how to determine the different currents by applying the KVL applications. Okay, so in the mass, we are applying KVL applications, but to determine the different currents, we are going for finding determinants and Cramer's rules instead of comparing the equations and eliminating the terms or parameters. Okay, so by using determinants and Cramer's rules, this equation, this finding of different currents, that becomes simple. Okay, comparative to the eliminating the terms or parameters. Okay, so yes, we are applying this KVL applications for different mesh in the circuit. Mesh is it is a type of loop, but it can't further divide it into another loop. Okay, so we can't repeat in mesh. Okay, mesh is one type of loop, but it can't further divide it into another loop. Okay, so here we are going for the determinant. So we need to draw the matrix form, and according to the matrix forms, uh, we are going for finding the currents. So here four masses are given, and accordingly here equations are given. But according to the rules, these equations are written wrong, or you can say mathematically it is right by shifting this minus term on RHS side on you have already zero, so these equations mathematically is right. But before uh, directly applying this equation, uh, just briefing you how to calculate this mass analysis. So for the first mass, you can see that the current directions. So I can write I am traveling negative to positive for the VS2 source. So what can I write? Positive or negative?
Positive.
Positive.
So just I am writing here VS2. Then for R1, for R1,
Negative.
Negative.
yes,
Minus.
Negative.
minus I1
Negative.
R1. Then for V7, V7 is given. For R7, we have two current. So minus R7, and you are applying for the current loop I1. So this you can write I1
Determinant
minus
I1 minus I2.
I2.
Minus I2.
Yes. For R5, same two currents are flowing I1 and I3 through R5. So you can write minus R5 I1
I1
minus I3 equal to 0. Okay. Suppose you can shift this minus sign as you have 0. So you can also write this equation in like this also. Minus VS2 plus I1 R1 plus R7. Can I change here, or is it right inside?
Plus R.
Can I write like this?
Correct. Yes, sir.
Yes.
Yes, sir.
So this equation is written like this. This minus sign is interchange. So instead of this, this V is nothing but IR, voltage drop. So you can also write like this V1, V7 and V5. And after that, you can substitute this V1 equal to what, V7 equal to what, okay? Are you getting me?
Yes, sir.
Same
Yes,
for
sir.
same for
Yes,
mesh
sir.
2.
Yes, sir.
Same for mesh 2, it is written like this. It is taken positive, but it should be negative. Okay, then sign is interchange. This is, suppose I am writing to minus V2, then plus V6, then plus V6, then for R7, what can I write? Plus V7 equal to 0. Okay. Now I am interchanging the sign. V2 minus V6 minus V7 equal to 0. So this is written like this. Just I am interchanging the sign by mathematically. Same for the third. I can write this for the third according to the rule. I can write minus V5, then minus Vs1 minus V3 equal to 0. Okay, I am just interchanging the sign, so it becomes V5 plus Vs1 plus V3 equal to 0. Okay, and for the fourth, I can write I am traveling negative positive, so Vs1 positive, then V6, V4 also negative, V8 that is also negative equal to 0. Or I can write these equations minus Vs1 plus V6 plus V4 plus V8 equal to 0. You can keep it like this also. You can keep it like this also. So when you draw the matrix, your diagonal element should be positive. Okay, so that's why just we are interchanging the sign because we are applying for determinant and Cramer's rules. Okay. Just now we are moving to the. Okay, so here you can see this equation is substituted by the voltage this I1 R1. Okay, we are substituting this by voltage of V equal to IR. So these equations we can write like this. Okay, in terms of substituting V equal to IR accordingly, or you can directly write in terms of, okay, you can just by showing the voltage source, or you can also directly write in terms of IR. Okay, so you will get these four equations. Now these four equations that you need to convert into forms, and you need to find the determinants. Okay, you need to find the overall determinant, then you have to go for the d1 d2 d3 determinants according to the unknowns are given. Okay, so you need to draw three matrix for the coefficient, then unknowns and the constants. So you'll get three matrix. Okay, so suppose unknowns are the I1 I2 I3, then if the coefficient that with unknowns that is on the coefficient, and on the RHS side whatever value we have, that is known as the constants. Okay, so just we are moving to the examples, we'll get the idea. So you will get this type of matrix. Okay, by separating the terms I1 I2 and I3. Okay, just we are taking the common I1 I2 and I3 terms. So you'll get this coefficient, these unknowns, and this voltage source on this voltage value on RHS side. Okay, so just we are arranging this coefficient of I1, I2, I3. Okay, this is your first row. This is your first row for R1, R1, R5, R7, R7, R5. Okay, just we are making the matrix of this coefficient. So that is your resistance value. Okay. Here we have for I2 we have 0 resistance. Okay, so these are the coefficient of unknown. The unknowns are I1, I2, I3 and I4, and these are the voltage value that is given already, so we are taking in terms of constant. So just we can write like just we have four unknowns, so we have 4 by 4 matrix. Okay, for I1, I2, I3. So first what we need to find, we need to find overall delta, or you can notify D, or you can also give notify by the lambda. Okay, so just find out the overall determinant, then go for the determinant D1, D2, D3, D4. Suppose I want to find D1, then I need to replace coefficient of I1 by this voltage value. So I have to replace this column by this voltage value for finding D1. For finding D2, I have to replace this coefficient of I2 by this voltage. So I am replacing this coefficient by this voltage value. For D3, I am just replacing coefficient of I3 by this voltage value, and for D4, I am replacing coefficient of I4 by this voltage source. Okay, so you can find this overall determinant and D1, D2, D3, D4 determinants. Then you can go for I1 equal to determinant D1 by D, I2 equal to D2 by D, I3 equal to D3 by D. Similarly, you can go for I4 equal to D4 by D. Yes, that we'll see in example. So this is Cramer's rule. Okay, our diagonal element, we are just, you can see here, we are keeping just positive. Okay, so that's why we are interchanging the sign. So in how to apply this Cramer's rule? So here linear equations are given, 3 linear equations. Okay, so in the equations, this x1, x2, x3 are known as unknowns. Okay, these are your this a11, this all are your coefficient, and this is your constant. Okay, so you have to make the matrix. So you have 3 unknowns, so you have 3 by 3 matrix. So first you have to make the matrix of this a11, a12, a13. Okay, and then you have unknown matrix x1, x2, x3, and this constant. So this is converted by Cramer's rules, so we'll get this type of matrix. Okay, so after making the matrix, find out the determinants. Okay, overall determinant delta D, or you can write delta, then D1, D2, D3. Okay, so by finding these determinants, you will get these unknowns x1, x2, x3. Okay. So this is the matrix form for the, if you have 3 linear equations are given, so you can apply this Cramer's rule for determining different currents or different unknowns. Okay, so if overall determinant that should not equal to 0, so then the system has unique solutions. Okay, so overall determinant should not be 0. So according to the Cramer's rule, you can write x1 equal to d1 by d, x2 equal to d2 by d, x3 equal to d3 by d. Okay, so for finding x1, we need to replace this coefficient of x1 by this constant. Then for x2, we need to change this constant, and for x3 we need to change by this constant. So we'll get this d1, d2, and d. This is the overall determinant. That is your overall determinant d. Okay. Anyone having doubt up to this? How to find this determinant?
No, sir.
Okay. So now
No, sir.
we will move to the example. So this is your okay. This is your determinant. Okay. This is your overall. Then just we are replacing by constant. Okay. So here we first column is replaced by constant for D2. Second column replaced by constant for D3. Third column that is replaced by constant. Okay. So this is overall, just we are keeping as it is, just we are replacing this. Okay, this is the constant that we replace, this is the constant that we replace for finding individual this d1, d2, and d3 determinants. Okay, now here example is given. Determine the mesh current I1, I2, and I3 for the network. So anyone can tell me the equations for the mesh 1? For the mass one equation, we are traveling
50
50 years
minus
10 I1
10 into I1
minus 10,
minus 10 I1
minus 5
minus
into
50 5
I1
I1 minus
I2
I2
I1
I1
minus
minus
I2
then
minus 3
minus 3
I1
I1
minus
minus
I3
I1
I1
I1 minus
minus I2
I3
is equal
equal
to
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 0.
0.
0. Okay. For second,
Mm,
10
minus 10
minus 10. Okay.
10
Minus
and
10
minus I2.
plus
minus
minus.
I2
Okay. Just you are just telling me from here, so I am moving here minus 1
minus 1
I2 minus
bracket
I3
I2 minus I3
minus 5 I2 minus I1 minus 2 minus
I2
2 I2 equal to 0. And for the third,
minus
minus
5
minus
minus 5
minus
3
I1 minus
I3 minus
I3
1
minus I1
minus 1
minus 1
I3
I3 minus I
I2
minus I2
equal to 0.
equal
Okay.
to 0
Now you have to separate this term, just taking the I1 term. So here you have I1, here this is I1, and this is your I1. Okay, just separate the term for I1, I2, and I3. Same here. Just here you have I2 term. This is I2. Okay, this is I2. Just separate the terms for I1, I2, and I3. This is I3, I3. Okay, just so you'll get the three equations just that I am showing here. So equations are already written, so that I am showing you directly. So you can see, okay, 50 minus 10 I1 minus 5 I1 minus I2 minus 3 I1 minus I3 equal to 0. So you can write 50, 18 I1, so minus 10, minus 5, so minus 15, and minus 3. Okay, so this minus 10, this minus 5, and this minus 3. So that is minus 18. So I am shifting on RHS. So that is 18 I1. Okay. Minus 5 I2. So this is your minus 5 I2. So that becomes plus, but I am shifting on opposite on RHS. So that is minus 5 I2. And minus 3 I3. So this becomes plus, but I am shifting. So this is your minus 3I3. Okay. So this is your first equation. 50 equal to 18I1 minus 5I2 minus 3I3. Okay. This is equation 1. This is equation 2. Okay. Minus 2I2 minus 2I2 minus 10 minus 1 I2 minus I3 minus 5 I2 minus I1 equal to 0. Just we are separating the terms. This minus 10, this is minus 2I2, minus 5I2, and minus 1I2. Okay, so 5, 7, 8. So that is your 8I2. We are shifting. Okay, minus 5I1. So this is minus 5 into I1, that is plus, but we are shifting the term. So this is minus 5I1 and minus I3 plus, but by shifting this is minus I3 and this is minus 10. Okay, we are shifting this term I1, I2, I3 on RHS side. So this is your second equation. And third equation, so you can see minus 5 minus 3 I3 minus I1. So you can see minus 5 minus 3 I3 minus I1 minus 1 I3 minus I2. Okay, so just we are writing the equation in I2, I3, I form. So you'll get three equations. Okay. Now make the matrix form. So just you need to make the matrix of this coefficient of I1 and this unknowns I1, I2, I3 and this constant value. Okay. So the matrix will form like this. Okay. 50 in previous equation, this is minus 10, this is minus 5. This coefficient, okay, for first equation 18 minus 5 minus 3, So you can see this 18 minus 5 minus 3. Okay. For second, minus 5, 8, minus 1. And for the third, minus 3, minus 1, plus 4. And these are the unknown, I1, I2, I3. Okay. Now tell me the determinant for this coefficient. What you will get? You can write delta for the determinant. You can write delta or D. Okay. This is your determinant.
Sir,
Yes.
sir, D equals to 293.
293. Okay. 293. Tell me D1. For the D1, just replace this column by these constants. Okay, so your matrix becomes your D1 matrix becomes like this. Your D1 is now 50 minus 10 minus 5 minus 5 8 minus 1 minus 3 minus 1 4. This is your D1. Are you getting D? What you are getting D? 293. Everyone getting 293?
Sir, it is coming 356.
356. Okay, second answer is
Yes, sir. 356.
356. Second answer. So which one is correct? 293 or 356? Majority?
356.
Plus
Okay.
356.
356.
356.
I am
356, sir.
looking this 356 according to majority.
356.
Okay. So this is the wrong answer. Okay. Now tell me D1. What is your D1? According to majority, answer is 356. Then we will verify. Okay. Answer is correct or wrong. Tell me D1 determinant.
One 175.
1175 D1. Okay, just I am writing here 1175.
Yes, sir. 117.
Yes, sir.
1175.
1175.
Yes,
Okay.
sir. 117.
1175.
117.
Okay. So D1,
1175.
I am writing here D1 equal to 1175. Okay. Now find D2. So in D2 matrix, you can write like, okay, for the D2, just replace the second column. So your matrix becomes 18 minus 5 minus 3 50 minus 10 minus 5. Okay, this is your D2.
Sir,
Yes,
355.
355.
D2 355.
355.
Okay, yes, I am writing D2 355. Okay, I am writing this D2.
Yes, sir. 355.
Okay, so D2 is 355. Now go for D3. Just change the matrix.
525.
525.
Okay, wait. So your D3 matrix that becomes like this. So D3, 18 minus 5 minus 3 minus 5, 8 minus 1. This is 50 minus 10 and minus 5. So D3 equal to
25.
5.
525.
525.
Just we are now
520.
we are verifying your answer. Okay. This answer just so your delta R is 356. Okay. So this is the resistance value. Okay. So you can just show it by in ohm. Delta R1 that is in ohm. Okay. Due to having this resistance value 1175. Delta R2 that is also 355 ohm. And this is 525 ohm. Okay. Now for finding I1, tell me the I1. I1 equal to what? Delta R1
R1 upon delta.
delta R. So delta R1 that is your 1175 divided by this 356.
3.3.
3.3
3.3.
3.
3.
ampere.
Yes.
Yes, sir.
Yes.
Yes, sir.
Due to having voltage and resistance value ohms, we have 3.3. I2
3.3.
0.99.
99.
0.99. Okay. 355, 356.99 ampere. Okay. This is your I3 delta
1.47.
1.
1.47.
1.47.
I will check 356, 1.47 ampere. And I
1.7.
equal I okay, we haven't I4, okay, just I1, I2, and I3. So I'm erasing this. So that's we are verifying 3.3, 0.99, and 1.47. So 3.30, yes, ampere. I2 0.99, and this is 1.47. Visible? It is visible. This answer.
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
Yes, sir.
Yes, sir.
So anyone
Yes,
having
sir.
we have number of students. Just I am hearing only 4 to 5 YGs only. So remaining one, are you getting this mass analysis?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes,
Yes,
sir.
Yes,
sir.
sir.
Yes,
Yes,
good,
sir.
good.
Yes, sir.
Now
Yes,
we are
sir.
moving to another example. Okay. This network is given. Just find out. We have three unknowns. Means we have to determine three currents I1, I2, I3 by mass analysis. Just get the three equations. Okay. And convert into the Cramer rule, means into the matrix. Find the determinants, overall determinants, then D1, D2, D3, or delta R1, delta R2, delta R3, and then find I1, I2, I3. Just get three equations. So in the equations, we can write for the first mass plus 7, 7 minus 1 in bracket I2 minus I1 minus I2 minus 6 minus 2 in bracket I1 minus I3 equal to 0. So this is first equation 7 minus 1 I1 minus I2 minus 6 minus 2 I1 minus I3 equal to 0. Okay, so this is your for by separating the term for I1, I2, I3. So minus I1, this is your minus 1 I1. Okay, this is minus 2. So that is your minus 3 I1. On RHS side, you have 3 I1. Okay, so this is your minus I2. So that is minus minus plus, but shifting on RHS, so that is minus I2. And this is minus 2 I3, that is your plus I3. Okay, plus 2 I3, so that is shifting on RHS, so that is minus 2 I3. And 7 minus 6, that is 1. Okay. For the second term, So you will get this expression for second, minus 2 I2 minus 3 I2 minus I3 minus 1 I2 minus I1. Okay, so here you can see this I2, so minus 1 I1 minus I2 minus 2 I2 minus 3 I2 minus I3 equal to 0. Okay, so this is 0 minus I1 plus 6 I2 minus 3 I3. And for the loop 3, we have the equations for the loop 3. This is plus 6 minus 3 I3 minus I2 minus 1 I3 minus 2 I3 minus I1 equal to 0. So this is your equation. So we have three equations. So in equation, anyone having doubt?
No,
No,
sir.
sir.
No, sir.
Getting
No,
this
sir.
same equations?
No, sir.
Getting?
No, sir.
Okay, so
Yes, sir.
now we have three equations. So you will get this type of matrix. Are you getting this matrix? 1, 0, 6, 3, minus 1, minus 2, minus 1, 6, minus 3, minus 2, minus 3, 6. If you are getting this diagonal negative, then you will get the negative answer for current, okay? So if we having this positive diagonal value, then you will get positive value. Okay, so this is your matrix. Now find out overall determinant delta R, then delta R1. So just replace the coefficient of I1 by 106. Okay. For I2, just replace second column by this constant, and for I3, replace this third column by this constant. So you will get delta R 39 ohm. Are you getting theta 39 ohm?
Yes, sir.
Delta,
Yes,
delta,
sir.
delta R1, delta R1,
117.
Yes, sir.
117. Good. Delta R2,
78.
delta R2, 78 ohm. Good. Delta R3,
117.
117.
117. Good.
117.
Tell me I1,
117.
I1, delta R1 by delta R.
3.
I1,
3.
3 ampere.
3.
Okay. I2,
2.
2.
Two.
I2, 2
2.
ampere. Okay.
2
I3,
I3. 3
સર
3
ampere.
મને
ampere.
ampere.
3 લખે છે
3
ampere.
ampere. And I4, okay. Just we have I1, I2, I3 only. Okay. Don't go for I4. So this is the answer. Mass current I2 and I3. Okay. Okay. Now I'm giving one example. Simple example. Just the answer. Okay. Just I am doing network. Simple network. So everyone can solve this. Okay. Simple example. According to the mass analysis, and you can apply Cramer's rule for finding determining currents. Okay. Please mute from your side. So this is 10 volt, 5 5 ohm. This is 2 ohm, 10 ohm, and 50 watt. Okay. Now find out current I1 and I2 by mass analysis. Determine current I1 and I2 by mass analysis. The simple example I have given, so everyone can solve it. So by applying KVL for the mesh 1, I can write 10 minus 5 I1 minus 2 so 10, and for the second equations I can write this is okay, this is plus 50, okay, this is plus 50, this is plus, huh? Okay. So I can write minus 50 minus 2 I 2 minus I1 minus 10 I2 equal to 0. Are you getting this two equation?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Now just
Yes, sir.
subtract the
Yes, sir.
Sir,
I1
sir, I1 equals to 5.5.
I1 5.5.
5.78.
Okay, I am getting two answer. I1 equal to 5.5 and second answer is 5.78. Tell me the which one is correct. Either 5.5 or 5.78. Other ones, what you have to say? 5.5 or 5.78?
Sir, I am getting 0.25.
I1.
Yes, sir.
Sir,
Yes,
I
sir.
want point two four.
I
Yes,
2.5.
0.25.
2.5, sir.
0.25.
yes,
Yes,
sir.
sir.
So
Yes, sir.
these both are wrong. I am doing wrong this. Which one is correct? Third one or this first or second?
Third one.
Third one. Okay, just I am locking this third one answer. Okay, 0.25. I2. Anyone getting other answer for I1?
4.1. Sir, 3.68.
3 point.
I1, I1.
I1 3.68.
Yes.
Sir,
Good.
4.12.
I1.
I2
I2 is equal to
4.1.
4.1. Okay, you need to write the unit.
Sir,
Okay, after
Sir,
the value. Okay. Yes, tell me.
sir, I'm getting I1 is equal to 2.75.
Good. 2.7. It's okay if you are
And
getting.
sir,
I2
I
is
am getting.
I2 is equal to
If you
Sir,
5
are
to 6.
yes,
Sir, I2
I
equals
am
to
getting
minus
I2 negative.
3.25.
minus
Sir, it means
3.25. Minus
25.
3.25. If you are getting
Sir,
different
I2
answer,
is
then
equals to
it's
minus 4.02.
I2
Yes, minus
minus
4.02.
zero.
4.02
If you are
ampere.
getting different answer means if you are trying for the example, that's good. Okay, but after practice, we'll get the
Sir,
correct answer.
I2 equal to minus
Sir, I2
4.125.
Minus 4.125.
125.
125.
Okay.
Sir,
Now,
I2 is minus
I2 is equal to
4.125.
4.6.
yes, 4.25. Okay. Then any other answer?
4.62.
I2 is equal to 4.62.
4.62. Okay. Then, so we can see for the same example, we are getting the number of answers. So that's good. If you are trying for examples, but get the correct answer in the exam. So now see the example. The answer is just I am telling you answer. The correct answer is I am getting here delta R is equal to 80 ohm. Are you getting 80 ohm delta R?
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Delta
sir.
R1 equal to 20 ohm.
Yes, sir.
Yes, sir.
Delta R2 is equal to minus 330 ohm. Okay. And according to the Cramer's rule, I1 is equal to 0.25 ampere. And I2 is equal to minus 4.125 ampere. So this is the correct answer. So just check your answer and you'll get this. This is the correct answer for delta R, delta R1, delta R2, I1 and I2. Okay. Just you made mistake in terms of finding determinant by changing the column by the constant. Okay, just you made a mistake in that, so you'll get this type of different answer, but this is the correct answer. Okay, I have given just simple answer, a simple network, and in that you need to you have to apply this mass analysis, and you need to get this I1 and I2. And in the assignment, I will give more examples for your practice purpose. Okay, so you'll get the correct answer in examinations. So in the examinations, just you need to write these all steps. Okay, don't just directly write down this delta R1, R2, I1, I2. Just you need to write matrix form. Okay, and just you have to go for the solution. So in mass analysis, anyone having doubt?
No, sir.
No, sir.
Because
No, sir.
after this we will
No, sir.
nodal analysis. Okay. If anyone having doubt, then I will continue in tomorrow's lecture for mass analysis. And if you are having not any query or doubt, then we will move to the nodal analysis. For the mass analysis, I will give some examples. Okay. So you can do practice at your home. So in this week, I will generate one assignment, but I will inform priorly. Okay. So then I will create assignment, and you will also get notification for this assignment, and deadline also will be there. Okay. For submitting the assignment, I will give enough time for this assignment submission. I will give 8 to 10 days. Okay. So I complete this mass analysis here. One minute, wait. Okay, so on tomorrow we have first lecture, so we'll do nodal analysis. So in nodal analysis, we will use KCL applications. Okay, so by KCL applications, we will find different node voltage. Here in mass analysis, we are finding mass current by KVL. In nodal analysis, by KCL applications, we will find node voltage, or you can say different voltage. Okay. So in that, just you need to identify different nodes, and you have to assume one reference nodes, and from that you can find those different node voltages. Okay, so that I will show you how to apply this node voltage in the circuit, and we'll move to the some examples. Okay, so I end my session here. So you can leave the session.